In this video, we're going to talk about topic 8.10, which is volume with a disk method revolving around other axes. So we're going to ask our essential questions. How do you calculate the volume of disk with a shifted axis? And the I can statement is I can calculate volumes of revolution using definite integrals on the disk method with a shifted axis of revolution. So in example 1, we're going to be revolving around a line that is not on a coordinate axis. So we saw in the last topic that you could revolve around the x-axis or the y-axis. In this one, we're going to move the axis. So we see that we have find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. Sketch the graph and draw the representative rectangle. So the first thing I'm going to do is I'm going to go ahead and sketch those graphs. I know that this one here is a parabola where its vertex is at 2 and it's upside down. So it's going to go, let's see, if I put a 1 in there or a negative 1 in there, either one, I would get 1. So I know it's going to go through these points here. And then I know that this is going to be a horizontal line at 1. So this is the region we're looking at. We know our representative rectangle, just to visualize this, would be like this. And then notice it says about the line y equals 1. So we're revolving about this line, meaning I am taking and spinning this yellow region around the green line. So I know I'm going to need bounds here in a minute, so I'm going to calculate those. Even though I can read them off the graph, just as a reminder, how do we get those? We're going to take this and set them equal to each other. So we'd have 2 minus x squared equals 1. I'm going to move the 2 to the other side by subtracting it. So 1 minus 2 is negative 1. Divide by negative 1, you get x squared equals 1. And then to undo the square, we take the square root. Remember, we put a plus minus in front. So you get x equals plus or minus negative 1, which is what we kind of estimated there when we were sketching the graph. The blue one is definitely my top, and the green one is definitely my bottom. So we're just going to do top minus bottom again. So for volume, we know we always start when we have a revolution, we start with pi. Our bounds are going to be from negative 1 to 1. And my top function is going to be the 2 minus x squared. And the bottom function, which I'm going to subtract, is going to be the 1. And then remember, when we're revolving, we have to make it a squared because it's technically a circle that was our cross section. All right, let's see if we can go ahead and integrate this all the way this time. So I'm going to simplify a little bit before I actually integrate. 2 minus 1 would be positive 1. We're going to square that dx. Since I don't have anything extra, I don't want to have to deal with the u substitution, I am going to choose to FOIL this out first. Just going to be easier. So I'm really going to do negative x squared plus 1 times negative x squared plus 1 dx. And let's see, when I do that, negative x squared times negative x squared would be x to the 4th. Negative x squared times 1 would be negative x squared. But I have a second one in there, which would make it negative 2x squared. And then 1 times 1 would be 1 dx. I'm going to go ahead and integrate that. So we've got pi. Remember, we add 1 to the exponent, so we get x to the 5th over 5 minus 2x cubed over 3 plus x from negative 1 to 1. And then we are going to go ahead and plug our values in. So let's see, we get pi. Let's see, 1 to the 5th is 1, so we get 1/5. Minus 1 cubed is 1, so minus 2/3, and then plus 1. And then we're going to minus pi, and we've got to put in the negative 1. Negative 1 to the 5th would be negative 1/5. Negative 1 cubed would be negative 1 times the negative 2 would be positive 2/3, and then minus 1. Let's see. I could distribute the, actually, there's no great way to do this. I could try to do my little, actually, this is what I'm going to do. I'm going to take my pi out front and factor that out. So I've got 1/5 minus 2/3 plus 1 minus parentheses negative 1/5 plus 2/3 minus 1. I'm going to distribute that negative in, so it's going to go positive, negative, positive. And then let's see if we can use the little trick to make our fractions easier. So I've got pi. Let's see, 1/5 plus 1/5 would be 2/5. Negative 2/3 and negative 2/3 would be negative 4/3. And then 1 plus 1 would be 2. If I was going to go all the way with my fractions, I would have to get a common denominator of 15. So let's see. This would be multiply that by 3, so I would have 6/15. Multiply this by 5, so I'd have 20/15. And multiply that by 15, so I'd have 30/15. So we've got 6, or actually negative 20 and positive 30 would be 10, right? And then 10 plus 6 would be 16/15 pi. Technically, on the AP test, if they did ask us to integrate this on free response, we would go ahead and we would stop here. Because as soon as we have it as a numeric answer, we stop and we don't make mistakes doing our final answer.